Okay. Suppose that a firm's production function is in the form of Q equals L times K. Q just represents the quantity that will be produced. L is the labor, K is the capital. Part A. What is the cost minimizing input combination of the firm? Okay, so we need to find this cost minimizing input. Basically, we're just asking how much labor and capital do we need to have in order to minimize our costs. Okay, so first things first, when you're when you're getting this cost minimizing input, okay, number one, write the cost function. Okay, so the cost function, okay, is this one. C, which is your total cost, is the wage rate for the labor multiplied by the number of workers. L just represents number of workers. W is the wage rate for the workers. Plus R, this is the rate of capital or the rate of renting the capital. K is the number of units of capital that you have. All right. Yes. So first we get our cost function. All right. Then also you're going to write down your production function Q equals L times K. All right. So colleagues, here we're going to use the Lagrange multiplier to help us find this cost minimizing input. Okay, the Lagrange multiplier just helps you find maximization or minimization problems with constraints. Okay. So first thing, when we're setting up this Lagrange function, all right, first thing you need to do is here in this production function, okay, just bring this L times K to this side. So it will be Q minus L times K, okay, because our Lagrange function is going to be like this. It's just a combination of the cost function and plus the production function with lambda. Okay, that's the Lagrange function. Okay, it's just your cost function plus lambda and your production function. Okay, so you're just combining the two. You put your cost function here, W L plus R K plus lambda open brackets Q minus L K. Okay, colleagues, this is always, it's the steps are always standard. Okay, when you're making your Lagrange function, there's your cost function and your production function. This adjusted production function where you bring LK over the other side. All right. So we simplify this function first. W L plus R K plus lambda, we're going to distribute it out. Okay, so you say lambda times Q, lambda times LK. Okay, that is the first thing you need to do. You set up this function. Okay, yes, because remember, one find the cost minimizing inputs. Basically, you're just trying to find what is the value of L and K. All right. So after you've set up this function here, you're going to need to derive it now. Okay. So first we're going to derive this function with respect to L. Okay, with respect to labor here. So if anything doesn't have an L attached to it, it disappears. Okay, so this RK, this lambda Q, well, they will disappear. We're only deriving the WL and lambda LK. Okay, so remember this L is like L to the power 1, right? So when deriving, you just multiply the exponent times the number in front of the letters. 1 times 1, you get 1. 1W. Then remember, you always have to subtract a 1 from the exponent. 1 minus 1, that is 0. So L to the power 0 is just 1. So when we derive this WL, we just get W. Okay. Minus, we come here to this lambda LQ. Okay. Even here, this L is to the power 1. Multiply 1 by the number in front of these symbols and letters, you get a 1 here. Lambda still stays as it is. This one, you subtract a 1 from it. 1 minus 1, that is 0. So L to the power 0 is just 1. So basically the L just goes because it becomes a 1. And K stays as it is. Okay, so this is our first equation here. W equals lambda K. We derived this function with respect to L, right? Yes. Any questions? Next, we're going to derive our function now with respect to K. Okay, so whatever doesn't have a K disappears. So here, this WL won't include it. This lambda Q, we are not going to include it. We're only deriving this RK and this lambda LK. So colleagues, as I said here, one trick you can just remember. When you're deriving this, if you remember when we derived L, this WL just remained as W. We just got rid of the L. So even here, when you derive this K, you will just remain with the R. Okay? Remember, K is to the power 1. You multiply 1 times the invincible 1 here, that is 1. When you subtract a 1 from here, you have RK to the power 0. K to the power 0 is 1. Okay? Minus, even here, lambda LK. Since we are deriving K, you just write lambda L. Okay? That's one trick you can use so that this doesn't give you problems. When you're just deriving this function with respect to that letter, when you go where that letter is, just remove that letter. Okay? But for formality's sake, here, K is to the power 1 also here. 1 times 1, you're going to get a 1. You subtract a 1 from here, K to the power 0. Okay, colleagues? Yes. So, with these two equations now, equation 1 and equation 2, okay, you can say you equate them to 0, so you say W minus lambda K equals 0. So W equals lambda K. Similar with this one here, R minus, this is still equation 1, okay? R minus lambda L equals 0. You say R equals lambda L. Okay, I've just made R and W the subject of the formula Okay, so these are the expressions we need. This one here, W equals lambda K, R equals lambda L. Okay. So you divide these two equations, okay? Basically, you divide these two equations, equation 1 and equation 2, you're dividing them. All right, so W equals lambda K divided by R equals lambda L. Okay, this is what you do to the equations. It's like you're dividing both of them. Okay, you get rid of your lambdas. Okay, so you're going to get W over R equals K over L. So you simplify this expression by cross multiplying. Okay, W times L, you get WL. R times K, you get RK. Okay. Then once you've reached this point, colleagues, make K and W the subject of the formula. Okay, make K and W the subject of the formula. So if we make W the subject of the formula, so let me put it here, beside here, WL equals RK. If we make W the subject of the formula, we just divide both sides by L. So W equals RK over L. Okay. Oh, no, not W. We're making L the subject of the formula. So we divide both sides by W. Okay. So L equals RK over W. And here we want to make K the subject of the formula. So we divide both sides by R. Okay. So K equals WL over R, and L equals RK over W. Okay. Yes. But we're not yet done. Okay. Because these expressions, this L equals RK over W and K equals WL over R, we're going to need to bring them back into this function here. Because we want the cost minimizing inputs of L and K. So those expressions, they will have to come back here in the production function. Okay. So we go back to our production function here. Remember, Q equals L times K. Okay. So if we substitute this, L equals RK over W into this function here. It becomes this. L equals RK over W times K. Okay. Then we simplify this expression here. Okay. RK times K, that is RK squared. RK squared over W. Remember, I want to find the value of K. Okay, so you cross multiply. Q times W, that is QW, equals RK squared. Okay, we divide both sides by R because we want to find the value of K. So we have K squared K squared equals QW over R. So to find the value of K, we get the square root here. And you're going to say K equals QW over R. So this is the cost minimizing input of capital. Okay. If we had values of Q, W, and R, we would have find out how much capital we need to minimize our costs. The only problem is here there is no numbers, so we are just dealing with letters. Okay. Yes. And we do the same for K. Okay. Q equals LK. So this expression K equals W over R, substitute it there. Okay, so Q equals L multiplied by WL over R. So L times WL, you get WL squared over R. Want to find the value of L, so you cross multiply, so you're going to have QR here equals WL squared. By both sides by W. So you remain with L squared equals Q R over W. Okay. Then get the value of L, you get the square root of both sides. So it will be L equals square root of Q R over W. Okay. So these are the cost minimizing inputs. This part A here. Cost minimizing input combination for the firm. Okay. It is this. So just a recap of this long process. All right. Step one, or your preliminary steps. So basically, okay, we have step one, write down your cost function and adjust your production function. Okay, we just brought LK over to this side. Reason why we're doing this, so we can set up this Lagrange function. Okay, I want to set up this function here, this language function. Okay, so you write your cost function and adjust your production function so that you can make this. Have you seen the language function here? It's just a combination of the cost function and the adjusted production function. After you set up this function, derive it with respect to L and derive it with respect to K. When you derived it with respect to L, we got W minus lambda K. When we derived this function with respect to K, we got R minus lambda W. Okay. Then once you've set up these equations, just make W and R the subject of the formula. Okay, have you seen W equals lambda K, R equals lambda L. Okay, and you list equation 1 and equation 2. After you have done that, divide equation 1 and equation 2, which you've seen here. W equals lambda K over R equals lambda L. You get rid of the lambdas so that you remain with this expression W over R equals K over L. Okay. And then once you remain with this expression, cross multiply so that you remain with WL equals RK. This is the expression that you want. And you want to make K and L the subject of the formula. Because these expressions will be put into the production function, as you can see here. We made L the subject of the formula. L equals RK over W. K equals WL over R. Okay. These expressions, you put them back in the production functions here, as you see, so that you find the value of K and L, the cost minimizing inputs. Yes. Okay. Now we're going to go to part B. Okay, where we have to derive the total cost function. Okay, derive the total cost function. So since we have our values of K and L, the cost minimizing inputs, input combination. Okay. Since we already have these cost minimizing input combinations, so now we're going to take them to the cost function because they've said derive the total cost. Okay, so part B, the total cost. Right, remember our cost equation C equals WL plus RK. Okay, so we already know, so we said W, already know the value of L. L equals square root of Q R over W, okay, plus R, then K equals the square root of Q W over R. All right. Yes. Now, we are not yet done. Okay, because we need to simplify this expression. Okay. Now, the way it is currently, we can't just multiply W times QR or cancel out the W's here. All right. So we need a way to adjust this W and this R so that we can multiply it by these square roots. Okay. So colleagues, if you remember, the square root of A squared equals A. Using this logic, okay, the square root of A squared equals A. So also the same, The square root of w squared equals w. Okay, we can apply this. So you can say the square root, we'll put here square root of w squared. We haven't changed the meaning of the function because when you square w squared, you're going to get back a w here. So we haven't changed the meaning of the function. Okay, we are just doing this so that we can simplify our expression. So here we have qr over w plus same with r here. The square root of r squared is just the same as r. Okay, so it's like we're moving back like this. Okay, because we want to simplify our function. Okay, so here we have r squared okay, here we have qw over r. Okay, so now since we've got square roots everywhere, we can now simplify. Okay, so this w squared, we can multiply it with this qre. This r squared, we can multiply it with this qw here. So when we do that, square root of w squared times square root of qr over w, when you multiply these two, you're going to get qr w squared. Qr w squared over w plus here square root of r squared times square root of qwr, qw over r. Okay, so you're going to have qw r squared over r. Okay, so we simplify. Here we can get rid of this w, okay, and we get rid of one w on top, so we're going to remain with the square root of q r w plus here we get rid of this r, and since there are two r's on top, we get rid of one r, so we have q r w also. Okay, q w r. Right, so now as you can see, colleagues, these are like terms here. Okay, q r w, q r w, so we can add them. Okay, this is law of sets. Okay, mathematical analysis. Yeah, I believe you learned sets in mathematical analysis. When you add these two, it's like there's a one in front of them. QR, square root of QRW plus square root of QRW, you're going to get 2 square root of QRW. Okay, so this is your total cost function. Ish. When you do a lot of these tabulations, even your brain, it feels tired. So we're going to the next part now. Part C. Find all the variants of the total cost function obtained in B. Okay, so okay, so the variance of the total cost function. Remember, there's what we call average total cost, ATC, or average cost. Remember from principles of economics, average cost is just your total cost divided by Q. Okay, yes. And then remember our total cost is 2 square root of Q W R over Q. Okay. Now we can simplify this further, colleagues. All right. This can be simplified further. Okay. So 2. Now remember, colleagues, laws of indices. A to the power 1 over 2, the same as the square root of A to the power 1. So this root here, going to convert it into a power. So you have QW R to the power half. Okay. Over Q. Okay. Over Q. All right. So what we can do is we distribute this half power to this Q here, this W here, this R here. So you have 2Q to the power half W to the power half R to the power half over Q. This Q is to the power 1. Okay. So remember, when you're dividing indices, same base, Q to the power half divided by Q to the power 1, you're subtracting this half minus 1. So it's like this 2Q to the power half minus 1 W to the power half and R to the power half. Okay. Half minus 1, that is negative half. So 2Q negative half W and R to the power half. All right. So remember, again, laws of indices. So here, colleagues, I'm applying a lot of things that you must have learned from mathematical analysis. Laws of indices, especially laws of indices. All these adjustments I'm doing here are from laws of indices. So Q to the power negative half, whenever you have a negative power, you get the reciprocal. So basically this Q goes down. It becomes Q to the power half here. W to the power half, R to the power half. Okay. Then we can now bring back the root. Okay. Remember, we do it like this: WR to the power half Just hold on, colleague. Hello. Right. Let me just finish your recording. Let me just finish your recording. Hold. Tell her people. Yes. Over q to the power half. Okay. And then you can write it like this: 2 square root of w r over square root over q. Okay. Which can simply be simplified further to 2 square root of w r over q. Okay. This is the average cost. Okay. Because when they're asking you to find the variance of the total cost function, okay, they want the average cost, variable cost, which is the marginal cost. All right. Yes. But since time is not with us, so next time we meet, we'll get the marginal cost. Okay. Which this lambda represents. See, when we reach this part here, which says interpret the language multiplier, this is similar to the marginal cost. This lambda here, it is similar to the marginal cost. Okay, the additional cost that you're going to incur when you produce one more unit.